What's up, pre-calculus students? We are going to do a problem now involving vectors. This, my friends, is chapter 8. And we are going to look at a problem involving a ship, read it real fast, leaving port, sailing 75 miles in a direction, 35 degrees, bless you, north of due east. So what I'm going to do is I'm going to lay out a compass first. All right, and I'm going to focus in on the first quadrant. So I'm going to make a little strategic XY axis, which is going to become a compass here. Let's get back to that. So this will be north, east, south, and west. And I am going to show you how this all works. So this boat is leaving port, and is the magnitude of this is 75 miles in a direction 35 degrees north of east. Now watch. 35 degrees north of east is simply going this way. Okay? So it's north of east. So the angle is going to go in this direction like this. North of east. This would be south of east. Okay? See how that works? Let me get rid of all those little lines right there. All right, whoops, one too many. West. So if we do 35 degrees, and I just kind of eyeball a resultant vector, my goodness, let's undo that too. I like straight lines. 35 degrees, probably about like that right there. And we'll call this angle 35 degrees. And the magnitude of this is 75 miles. So we talk about vectors having magnitude. Yesterday, that was the whole focus of this, magnitude and direction. Sorry, I'm writing fast. This is the magnitude, 75 miles. That's how far the thing goes. The direction is 35 degrees north of east. This is the magnitude and direction. That is a true vector. It wants to know, though, find the magnitude of the vertical and horizontal component vectors. Let me show you what that's all about. If this thing is going diagonally upwards to the right, that means it's also going to the right. And it also means it is going up, like so. Okay, so it's going to the right and up. We call this going in the X direction and going in the Y direction, because up is Y and right and left is X. These are the component vectors. Going to the right and up means going diagonally. Okay? What this wants to know is how long is Y and how long is X and how long is Y. So to do that, this involves simple trigonometry. If I'm going to find X first, right here, that's from this angle, 35 degrees, that's the adjacent side. It's just basic right triangle trig. This is, in fact, right triangle. So this is X and being the adjacent side, and this is the hypotenuse. Adjacent and hypotenuse all day long is the cosine. So the cosine of 35 degrees is X over 75. Now, every time we do trigonometry, this type of stuff, you either have to multiply or divide. Do I multiply or divide, people? You multiply. So I take 75 times the cosine of 35, and I'm going to get, rounding to the nearest mile here, I'm going to get X somewhere, I'll use squigglies, around 61 miles. Does that sound right? Somewhere around 61 miles. This is the horizontal component vector. So if you're like, I don't know what a horizontal component vector is, this is what it is. It's how long that line is right there. Now, how far up did you go if you start here? This boat that came out of port starts here and ends here. Check this drawing out. Okay, there it is. That's a boat. And it starts here and ends up here. How long is this? How far up did it go? Well, that's opposite side over hypotenuse, and that's the sine. So the sine of 35 degrees equals Y over 75. And I would multiply again. So 75 times the sine of 35 would equal around 43 miles. So this would be 43 miles. Now it asks you just to find the magnitude of the vectors because the direction's already there. This is east, of course, and this is north. Vectors always have those two things, magnitude and direction. And if you've again been confused about that, just one more time. This pink line is the magnitude, and it's called the resultant vector, and it has a magnitude of 75 miles. This is the magnitude, and the direction 35 degrees north of east. Have a good day.